We are going to look at understanding vector subtraction. So we've seen vector addition, now we're going to look at vector subtraction. So we have two vectors here. We have a vector v and vector w, and we're subtracting w from v. Vector v is 6, 2, vector w is 0 and -4. And what are the components and magnitude of the directions? So again, we're now going to have to describe the components, magnitude, and directions of these two vectors. So let's first take a look at the graph, because part of this is graphically, and so we should look at the graph. So here is the graph of those two vectors. And the thing with w is that we're subtracting it. So what's going to happen here is I got to change basically the w. I need to make this negative w, and negative w is 0, -4, so this would be 0, 4. So we're looking at something like this. Hopefully, you know what, I'm just going to get a straight line. Because I was going to try to freehand that, but you all have seen my freehand straight lines. We're not going to do that. All right, so there's my new vector. Now the thing is we're going to kind of create a parallelogram off of this. So I'm going to keep this, and I'm going to go here, because subtracting is adding a negative in our case. So we already took the negative here, and now we could do our parallelogram. So there's our parallelogram, and I'm looking at the vector that goes here. I'm going to get this green to draw it in. So graphically, there is my nice, beautiful vector, and this is the vector, this green vector right here is the vector v minus w. And if I'm looking at that, the terminal point is at 6, 6, so we could say that this vector v minus w is at 6, 6. Because the terminal point, if I were to end it, would go here. We're continuing on, which is why we have these type of brackets, but again, it's at 6, 6. Now the components, if I were to do this algebraically, I'm going to choose this red for algebraically, is I would have vector v minus vector w, and this is going to be 6 minus 0, comma, what is this? 2 minus a -4. And in this case, we're going to have 6, comma, 2 minus a minus, this becomes a plus, so that's going to be 6, 6. So we get the same vector algebraically. Now the direction. Now we need to know what the direction is. And we've talked about the direction before. We've seen it in other examples. We're going to use the inverse tangent or the arctangent to find the direction. I'm going to take each of these components. Remember, this is y, this is x, tangent here, theta. If I'm looking at this theta right here, that's not very bright, but if I'm looking at this theta here, we're looking at opposite over adjacent, which is going to be y divided by x, which is going to be 6 divided by 6, which is 1. And thinking about when tangent is equal to 1 in quadrant 1, so tan -1 of 1 is going to be 45 degrees. Or if you put pi over 4, that works as well, but I'm not quite sure exactly what the editor would take, so, or the user interface will take, so I'm going to keep it as degrees since that is how the example plays out. Okay, the magnitude now. The magnitude is going to be v minus w, because that's our vector name, is going to equal this guy squared plus y squared. 36 plus 36 is 72. Let me rewrite that a little bit cleaner. I was going to put 27, and I don't know why I was going to put 27, which is approximately 8.5. Okay, so subtracting the vectors graphically or algebraically results in the same difference. So we get the vector 6, 6. The magnitude of vector v minus vector w is 8.5, and the direction is 45 degrees. All right, guys, so this is the subtraction of a vector. Pretty straightforward, not too bad, but if you have any questions, always feel free to ask, and I'll catch you in the next video.